Hello everyone, so welcome to my channel. So today we are going to do Leetcode daily challenge, maximum performance of a team. So in this question, as you can see, this is hard level question, so surely it would be somehow trickier one, but we'll get out of that trick also and design an algorithm out of the same and get into it. So without wasting any more time, let's head over to the question, then we'll see the constraints and the example out of that, and then intuition and the code. And yeah, surely time complexity or space complexity also. So you are given two integers n and k and two integers arrays speed and efficiency both length n. There are n engineers numbered from 1 to n, speed of I and efficiency of I. This simply represents speed and efficiency of that particular engineer, which is that ith engineer respectively. Now choose at most k different engineers out of n engineers to form a team with maximum performance. The performance of a team is the sum of their engineer speed multiplied by the minimum efficiency among their engineers. Return the maximum performance of this team. Since the answer can be huge number, return its modulo 10 raised to the 9 plus 7. So as we read this question here, we can see that we are given the speed and efficiency, right? And how performance is being calculated, and that is we are required to return. So let us start. So the thing is that they are given with that we are required to choose at most k different engineers, and k is being given to us here, and out of those engineers only, right, to form the maximum performance. And how this performance is being calculated? So the performance of a team is sum of their engineer speed. So out of this particular whatsoever k speeds we will select, we will require to sum them and then multiply by the minimum efficiency. So out of this whatsoever minimum of k efficiencies we will select, we will be required to multiply with this sum. So that would be come out as a performance, and this is the answer we are required to return. So they are returning 60 here. So here you can see that we have maximum performance of team by selecting engineers 2, because k value is 2 with speed 10 and efficiency 4, engineer 5 with speed 5 and efficiency 7 is the, here we are adding up the speed, and minimum efficiency out of both is 4, so here 4 would be multiplied with the same, and after doing this we got the answer 60. So this is the thing which we are required to do in this particular question, and that's the thing which we are doing here. Yeah, so let us take for this next example also. But now comes the part that are you able to figure out that what we are required to do in this question? The thing is that basically out of all these efficiencies, we are required to have the minimum efficiency. That is the thing. But minimum efficiency, that also for only k engineers which are being there. And corresponding to those efficiencies, we are required with the maximum speed. Means the trickier part here is that this efficiency should be in such a manner that we get out the minimum out of those k engineers, not only minimum out of the whole efficiency array, but the minimum out of those k engineers. That is required here. And the next thing which is here is the speed, and the speed should be maximum, and that speed should be maximum among those k engineers. Not, by the way, not only those k engineers, but out of this whole k speed array. But the thing is that it is a sort of, means speed and efficiency both are interrelated with each other, so we are required to do ups and downs in both of these, and that is the only trick we need to come up with. So let us first check for the constraint, then I'll explain you that thing also. So here the thing is the k value that is up to 10 raised to the power 5. So it could go to such a longer extent, that is 10 raised to power 5, and then k dot length is n. So basically, and even the efficiency, so both of them could be till n, and the speed of it can go till 10 raised to power 5, efficiency can go till 10 raised to power 8. So basically the answer here could be, because first we are doing sum and multiplying with something, right? So it could be long integer. So that's why they were saying to do modulo. So we will be doing that at the end. Means as per these constraints, we are able to figure out that it would be a long answer. So now let us go again back to the explanation. So as per the explanation here, speed and the efficiency which is being there. Now here we are required to get the k engineers, right? Efficiency should be minimum. Now the thing is that if we choose some data structure in such a manner that we are easily able to access whatever is minimum or maximum out of the pair which we can form, because speed and efficiency both are associated with each other, and with a combination of both of them we will be able to figure out with the performance. So that's why we just don't need to analyze the speed, or we just don't need to only analyze the efficiency. We need to analyze both of them together. So in that sense only, first we are required to associate both of the speed and efficiency, and after associating them, then we are required to perform our required operations. So thing is, first we will be associating them, right? After associating them, then the thing is we will be sorting them. And now comes the part that how we are required to sort them. We will be sorting them as per the efficiency, and that also not in increasing order but in decreasing order. Why in decreasing order? So that we get the at max efficiency at the top, right? And corresponding speed also we will be able to figure out according to that only. So if we are required to get rid of that particular max efficiency, right? So we can easily get rid of that there only, because we are just required with the k set of engineers only. So that's why we are doing that all things in decreasing order, so that we are able to eradicate all the n minus k engineers from that set. So that's the thing. And now comes the next part about the speed. Speed would also be sorted in decreasing order only, and we will be eradicating all those speeds which are basically correspondingly associated with this efficiency. See, the thing is that all the efficiency, when we will be sorting the efficiency, although it will take time, I guess let me pause the video and draw the diagram, and then I'll show you that what I really mean to say. Okay, so now I have drawn that. So what I mean to say was, see, in this efficiency, then we are sorting them in decreasing order, right? So corresponding speed will also be sorted in that manner only, as we are having all the unique numbers here. If they would have been equal numbers, right? So then it would have been sorting the speed also with that speed which is basically greater, that would have been come at first. The same way we sort a 2D vector in increasing order. So in that way only we can sort this 2D vector in decreasing order. So now comes the part. So while choosing k engineers, we will be able to eradicate our k minus 1, or not k minus 1, n minus k engineers at this point only. So the thing would be that we will be having the speed at our whatsoever data structure we choose. So in that, if we choose a data structure, we are able to eradicate all the minimum speeds, right? So when we will be putting this particular minimum speed there, right, and then next minimum speed would be this one. So it will be like in this manner only. But according to that data structure only, we will be able to pop out this minimum speed. And as we require maximum speed, so now the next thing which we will be having would be this one, right? And so we have still one space, so we will be pushing this one, this 2 in our what we say in our data structure, and corresponding to that, now we are having these minimum efficiencies. So like this manner only, as we proceed forward, according to that only we will be able to figure out with the maximum speed and within minimum efficiency. So that would be the whole thing in this particular question, and that's how we are going to do in this. So for this particular fact, we are first now required to choose a data structure for the same. So I guess as per the explanation now you would have got hint that we are required to use minimum heap here, basically a priority queue. So according to that only, we will be basically popping out this particular speed, means all the minimum speeds, and corresponding to that, those efficiencies would be collected with us. And at the end, the final answer which we will be getting, that will be the minimum efficiency and the maximum speed sum. So let us first go to the algorithm and then I'll show you the code. So here the thing is that we are basically given with speed array, efficiency array and k, and both of the speed array and efficiency array are basically associated with each other. Now comes the assumption part, that let us first assume the present chosen efficiency E is minimum. So in that manner only we were sorting that and choose k highest speed whose efficiency is greater or equal to k. So like this only we are going ahead with our minimum heap. So the algorithm basically which follows for the same is that we are making pair of efficiency I and speed I because both of them are being associated, so that's why. Then we are sorting in decreasing order of efficiency, so that when we are processing for the speed, then we can easily able to eradicate all those speeds which are basically in decreasing order, not in decreasing but the minimum speeds which are being there, we will be easily able to eradicate them. And as we are eradicating at that particular moment, so those highest efficiencies would also be popped out because they are associated with that, right? So that's the thing here. Now for all that scenario, we will be using a min heap to get those k maximum speed with least efficiency, as all min speeds would be popped out. So this is the whole context of this tricky question. Basically the thing is that first we are decreasing first we are basically sorting in decreasing order of efficiency, and then as per we are using min heap for our speed, so we are popping out all the minimum speeds from that, and corresponding highest efficiencies would have been popped out till now, and then at the end we will be left with minimum k efficiencies and highest k speeds corresponding to those minimum efficiencies. So that's the whole thing about this question. Now comes the part for the coding and even the time complexity. So let us go through that. Okay, 1 minute. So here comes the part for the coding. Now let me show you about the coding part of the same. So at start I was thinking in that manner only. Speed is maximum and we are required to get the efficiency minimum of all the engineers which being chosen, that is k. So the time complexity would be order of n log n plus n log k. N log n would be for the sorting of the decreasing order, right? And then n log k would be for the fact that n would be for arranging them, and then k would be basically for those priority queue elements, means at most k elements would be there in priority queue, right? So that's why. Yeah, so now comes the next part is the space. So space would be n plus k because we are basically having our array which is having n elements, and k would be for the priority queue. Now this is the coding part for this particular question. Let me move it here only. Now for the coding part. This is a vector which is being used for associating our engineers corresponding to speed and what we say as efficiency. Now here we are filling those. So basically in this engineers vector of vector, here we are taking vector of pairs so that we can pair them out and then we are basically having the efficiency corresponding to that speed in that. And next we are sorting them. We are sorting in decreasing order of efficiency, because efficiency is the first in that pair, right? Then we are taking this speed sum. This speed sum will help us to get the sum, so that at the end we can easily able to multiply our efficiency with the same. Then here we are having the priority queue. So in the priority queue, here we are taking the vector of n, where all the states would be stored, and as it is C++, right? So C++ by default of max heap, so we are making it a min heap. That's the thing which we are doing here. Now for auto and ES, that simply refers to that we are getting a pair out of the same. We could have also used here as like this pair int comma int, like this way, but some more syntactically some more things are used here, so that as just like this it will show error. So this is the new convention for C++. So in that we use auto and then ampersand, and then in the square brackets E comma S, which simply represents that E will be getting the first part of that pair and S will be getting the second part of that pair. So out of this engineers, basically engineers is this particular vector which we have taken. So now we will be adding up that speed and then pushing that speed into our min heap. Now comes the next part. Now we are required to check for if our min heap size is basically greater than k, then only we will be proceeding further. If our min heap dot size is basically greater than k, then we will be proceeding with further for popping out the elements out of that, because we only require k elements in our min heap. So that's why we are decreasing our speed, that's a speed sum, with the top of our min heap, because we are just required with the maximum speed. So that's why min heap will help us to eradicate the minimum speed. So that's what we are doing here. And here the answer, now we are also required to update the answer. So the new answer would be directly answer and speed sum, which is the new speed sum which we will be getting here into E, and that E would be out of this particular. So this is the thing which we will be doing here, and at the end we are required to return the answer, and that answer we are basically required to return by doing the modulo. It's all because of the fact, because we will be getting an answer that would be in long int type, and our return type is basically int, which will show us errors, right? So that's why we are required to do modulo. That's what we are doing here. So yeah, this was all for this particular question. If you have any doubt, but to be honest, today's question was really interesting. Since it was trickier, and somehow it even got me to this, because before making video I need to make explanation also. So for that also I was required to do a lot of dry run. Then only I got to know about this particular solution. So yes, that's why today's question is really interesting one. So yeah, hope you like this explanation, and if you have any doubt, you can directly comment that down. I will explain you in the comment itself, or whatsoever method you want to know in that. So yeah, this was all for this particular question. If you like the explanation, please do like and subscribe to my channel, and do share among your friends to support my channel. So yeah, this was all. Thank you.